Welcome to lesson 11. In this lesson, we're going to be looking at the validation of a HVAC to give an example of how a validation process would occur. So number one, we're going to look at what are P&IDs. Number two, then we're going to look at the validation process for a HVAC. So P&IDs stand for piping and instrument diagram, and they look something like this here, and they're really important documents. All modifications on them have to go through change control on a pharmaceutical site. They are controlled documents. They have a very logical layout. They use standard symbols, and all components have a tag. The tag and the component must agree with the tag on the P&ID. And you can see here, these are all the tags for these pieces of equipment. They show a line diameter, but they don't show the line length necessarily, so they're obviously not to scale. The vessels and equipment are obviously not to scale either. In your appendix section, there is a YouTube clip which goes through all of the details of the P&ID drawing and what all of the symbol means, and it's worth having a look at it. Your P&ID then, in addition, will have a list of all your tag numbers. It'll show you what your equipment number is, and it'll give you a description of it as well, so that you know what everything is and where it is. This is what an isometric drawing of a reactor would look like. So it's an engineering drawing, and it's got all of the details on it. And then this is a 3D image of the reactor. Your isometric drawings then of your pipe system might look something like this. So you can see the flow, and you can see where the valves are. And it gives you an idea about what the process looks like. So we're going to hand over to you. You've got a new job as a site manager, and your first project is to set up a reaction vessel number 10. This vessel is currently manufacturing one product, Lipitor, at the moment, but you want to add a second product, Viagra, to that line also. So you need to put in place a very good line clearance to make sure every single trace of Lipitor has been removed prior to running the Viagra product. You have to turn the following P&ID into an operational and functional system.
P&ID drawings are very confusing looking. There's a lot of going on in them. So basically what you're looking at is you're looking at all your lines in your pipes, your valves, and your reactors, and all of the equipment that is on a particular line.
When you look at this P&ID, you can see the reaction vessels, you can see the lines, you can see the circlets and the valves, and all of the boxes. So these correspond to the different instruments and the setup of pipes that are leading to and from the vessel that are connected all together. There are also sensors in the P&ID drawing. So these show temperature, the level meters and flow meters as well, and how they're connected and where they're connected to. All of these are critical to the quality of the product, and if there are contaminants present, there will be product rejects, and then you'll have patient safety compromised as a result. This is a huge project to undertake. So as the project manager, what are you going to do? Just take a minute to think about how you might proceed with this project. So obviously the first thing you're going to do is get the right people together. Who will you need on your team? What is your objective? How are you going to do it? And who's the right people to design the part of the project? The next thing you need to do then is to define the critical quality characteristics. What are the key things that are going to be important for the safety of the product and the quality of the product? And what are the product impact requirements? You're going to need to generate a user requirement specification to make sure that it is the right equipment for the job that you're looking for it to do, that it's made of the right materials, that it's got the right functionality for the equipment that you want, that the software is right, and that the tolerances are right as well to adhere to your specifications. Then you would conduct a factory acceptance test to make sure that you have got what you put in your user requirement specification. You would install it, and you would make sure that all the items on it are labelled and corrected as per your P&ID diagram, and that it's operating exactly as it should be. That would be your IQ. You would then install it, and you'd make sure that all the items are labelled and connected as per your P&ID diagram that we had a minute ago. And then you would check that it is operating as it should. That's the installation qualification that was working optimally. Finally, make sure that it performs as it was designed to do. So that was your OQ, checking that everything works as it should. So there's quite an amount of work to a project like that. I hope you got some of these steps. Examples of validation activities. So if we're looking at a validation activity to do with automation, things that you might be looking at, you might make sure that the program automatically opens valves, turns on the pump, fills the reactor to the certain level that you need it to. And you might test that worst case scenario too. And what would happen if it overfills? You would clock up X number of litres in the flow meter and check that they're correct. Then you would check things like that the agitator is automatically turning on at 20%, etc. So you'd put it on the automation, and then you'd check it in reality and see is it doing what it's supposed to do, and check that the whole recipe runs down. You'd also check things like what happens if it's stopped abruptly, or if there is a cut to power or anything like that. What would happen on the automation side? The instrument then, you might test level switches on the top of the tank to see that the high level switch will cut the inputs so that it'll stop the feeds into the reactor so that you won't have an overspill. You would check that the calibration of the instruments is okay, that it's working as it should, and that they are doing the job that they're intended for, that the calibration certs are all in place. Pressure test of equipment. So for example, if your reactor is normally working at a pressure of 6 bars, you would normally test it to 1.5 times what its normal rate is. So you might test it up to 9 bar. And you'd verify that the pressure loss over specified is within the specifications that you have outlined in your user specification manual. So then you want to do an equipment trial. So rather than wasting good active product, what you would normally do is use an inert material that would be inexpensive. That'll give you a good indicator to see if the equipment works with materials in it. And you get a lot of knowledge about your equipment from doing that. Typical commissioning deliverables and the responsibility matrix. So I'm going to put a copy of this into the appendix at the back as well for your lesson plan, because there's a lot of information in it. So the things you would start off doing, so you'd write your commission plan, and who's responsible for that? The commissioning leader, QA would be responsible, and the system owner, the project engineer as well. So you can see then you've got your commissioning plan, you'd write up your schedule, you do a budget for it, how much is it going to cost the company, your overall test plan, who's going to be looking after that. We want to look at the pre-delivery inspection plan and the pre-delivery inspection report. Both of those would need to be done. Your factory acceptance plan and your factory acceptance report. An inspection plan then, and an inspection report to go with that. Your functional test plan and your functional test report, and your system test summary reports, and then your final commissioning. So there's quite a body of work involved in performing commissioning activities, and these will be for direct impact systems only, because you would need the written reports to go with your validation project. HVAC commissioning for the office area, a case study. So HVAC stands for heating, ventilation and air conditioning. The manufacturing environment is really critical for product quality. HVAC is a hugely important utility in a pharmaceutical or biopharmaceutical plant. The HVAC is responsible for light, it's responsible for temperature in an area, it's responsible for the humidity in an area, so how much water or moisture is in the area. It's responsible for air movement. This is particularly critical in clean rooms. It's also responsible for your microbial contamination and your particulate contamination with your HEPA filters. So all of these things are really, really important in a manufacturing environment. Uncontrolled environment can lead to product degradation. So you could have product contamination resulting from microbial contamination or particulate contamination, or you could have loss of product and profit, because if you've got too much product being sucked out through your filters, you're going to be losing a lot of product as well. So having it working really well and appropriate for the area that it's set up in is vital for a HVAC system. An office area would generally be of a no quality impact, but it depends on its location. You could have an office area inside a manufacturing suite. But if it's an office area in an admin area where you've got finance people working and it's not connected to a manufacturing plant or a manufacturing area or unit, then it would probably be commissioned and not validated. To understand the air handling systems, we need to know what the components are. So a conventional air handling system has 4 subsystems. The first one is the air handling of the incoming or the fresh air. So this eliminates coarse contaminants and protects from frost if necessary. And in the case of air recirculation, the fresh air is also called make-up air. 2 is the central air handling unit, the AHU, where the air will be conditioned. So it can be heated, it could be cooled, it could be humidified or dehumidified and filtered, depending on what's coming in and what your specs are. And where fresh air is recirculated air, if there is any, it's indicated by a dotted line, and that'll be mixed. Air handling in the room is under consideration. So you will be talking about pressure differential here, so that you would keep the pressure higher on one side than the other, and that's to help particulate contamination from moving from a clean area to a non-clean area. You might need additional filtrations depending on where your unit is and what it's working under, and you have air distribution as well. And the fourth part then is the air exhaust system or the filtration system, what's going out. So number 1 here is our fresh air coming in and our make-up air that's going into the system. Second one then is our air handling system. So this is where you're conditioning your air. So whether you're heating it, cooling it, humidifying it, or dehumidifying it and filtering it as well. And this is our area under consideration. So here we've got an office area and we've got our treatment in the office room level. And then we've got our exhaust air going out. And again, it's checking the flow rate. It's going to be putting a filter on it as well. So what checks do you think you might do when you're commissioning a HVAC for an office area? So you would do a P&ID walk down. You would check sound measurements and vibration testing to make sure it's not too noisy. You would check the alarms and the interlock testing. You would look at the airflow testing in the ducts, and you would check the fan revs per minute and the amperage that's working in that. You might also look at the air pressure balancing to see what the air handling is like. You would verify the proper operation of air coils and fans. You would check the motor runs, and you would check lubrication. You check the safety and the startup features. Does the emergency stop buttons work okay? And have you electrical power checks? And you would check drainage then as well. You might look at the structural integrity test then of your HVAC unit and your system, and you look at the voltage going in, the resistance and continuity testing as well. The last thing then would be to fine tune the adjustment of the equipment, so balancing your air conditioning and looking at your instrument loops. Over to you, let's check your understanding. So what is a P&ID? Can you list some of the components of a validation strategy? Thank you very much for your time and attention. We'll see you for the next lesson.